Hello everyone, my name's Caleb Foster and I will be doing a walkthrough of Prelab13, and it's pretty tricky and involves a lot of pass-by reference, which of course is not possible in C, so it involves a lot of pointer variables and working with that. So once we have done the command to start the prelab, we will have these 4 files. And the make file is not very important, but it does change the way you compile your program. So instead of doing compile, you will be doing make, and then that will create a new program file called mu classes that you can run just like a.out. And right now there is code in Prelab13 that's already there, and it prints out the courses, prints out the students, and then prints out the students in the Computer Science 1050 class. So our goal for this prelab is to organize the courses by the instructor's last name and organize the students by their last names, and also organize the Computer Science 1050 students by last names. So let's look inside and see what's there. So we have 2 pointers initialized for this list of courses and the list of students, and then it prints out the courses here and prints out the students here. And step 1 is empty, as well as 2 and 4. But step 3 is done for us, and that's important because it changes the list of students here to the students in the Computer Science 1050 class, which is not clear how it's done, because if we go back to the files and try to look inside the university header file, we will see the structures they have, which is important for pointing to the right information. You have a course structure and a student structure, and we'll look back on this in a couple minutes. But you don't have the commands. And if you look in the library, I don't know if you can hear the tone, but I'm trying to hit tab and it won't open. If you try to do cat library to see what's inside, you get a mess. And so I just hit enter and it just said the command's not found, and that's perfectly fine. So we don't have to know what these functions do exactly, besides get students in course seems to create a list, and get all students creates a list, and print students prints out the list for us. So the first thing we should do is write some pseudocode, and our goal is to write a sort function for the courses. I think I'll tab this forward, and we can start that process by I think it would be a void function, and we can just call it sort, and I'm not sure exactly what the parameters will be just yet, so we'll leave them empty. So the sort function will require, for sure, an address, and it would be helpful to have the size of the list, And and we can keep it at that for now. So let's say, well, we don't know what type of pointer is, so we can't really fill in the parameter yet. What I will be trying to do is the challenge to make one sort function for both the classes and the students, and to do that will be a little bit tricky, but it should appear straightforward. What we can first start with is all the values in this program will be dealing with characters and will be sorted in ascending. So we can write a kind of skeleton for our program using that information. So we can say compare to characters, which we will be doing by simply an integer value. For example, a is equal to something, and b is equal to a number that's 1 greater than a, and so that would be true. And then if it's true, it would cause a swap to occur. So that means we'll have to have another function for swapping. With parameters, we're not totally, well, yeah, it will require a pointer, but it's not clear what pointer we'll be using right this second. So we kind of have a direction already, and we've seen how to do bubble sorts, and we've done that a couple times. So I think I will just write the swap function in that style. So we can say that some kind of we would have a hold function, or not function, hold variable, and then the hold switches with first entry, and then hold, or rather becomes, that's a better word to say, and then first becomes second, and then second becomes the hold value. And that's how you do a switch. And then you just, what a bubble sort would do is switch it over and over through the list, and then you would have to go through another time. So that means we would have to have some kind of way to tell when the list is fully sorted. And the way I like to do that is I just have a function such as while j, and then if the swap occurs, something like this will happen. And then the reason this is important is because j will equal 0 at the beginning of the loop, and then at the end of the loop, if no swaps occurred. So if this line here is never activated, the loop will end. And that's how we can tell if our sorting is completed. So the one thing holding us back from coding right now is how we're going to make these parameters, because it's trickier than it appears, because you can't pass the type that we're sending. So if we're trying to determine whether it's a student or a course, you have to somehow send that information over, but that's not possible in C to send the type as well. So what we can do instead is send a void pointer just to the first line of the list, the first line of the list, which would be applicable to either the courses or to the students type. So we can say void pointer, and we'll call this address. And we'll make it constant so that we only use it as an address. We won't be using it as a code to count or anything else. It will just be data. And this has the problem of not being compatible with pointer arithmetic and stuff. You can't use it as an array. You can't +1 it to go to the next item in the list, but you can do that process manually without using C's built-in structure by also passing in the size of the size in bytes of the structure, and then we'll start coding with that information given that we have it. So a comparison would be something like it's better to start off before that to make pointers that we can adjust and work with. So we'll call, since we're going to be comparing characters, let's make a character pointer, and we'll call this location. And then we'll compare those two locations. So we'll do dereference this. Whoops, spell it correctly. Yes. So if this item is greater than the next item in the series, which will be location plus the size of the file, because each each character step is a byte, so you can simply say the size is the number of bytes, and you don't have to. If this was maybe an integer, you might have to divide this by 4 to make it compatible, since it would be stepping 4 bytes each time. But since it's a character, it's 1-to-1, and you don't have to adjust it too much. But if this is true, then we will have to swap it, and maybe we'll call the swap function and put the location in as well as the size. And then this is where the J is important, because this means that a swap has occurred and it becomes, instead of 0, it becomes 1, and the loop continues again to make sure that everything's in order for another loop. So now we have a swap function that has a address, and an integer for the size. So we will have to create a hold value, and we will call that a character pointer as well, because you can't dereference void pointers. But what we're going to do is change each byte of the structures one by one instead of all at once, which is a little bit different. But if you want to have a program that can work with two different types, it seems best to do it this way. And we will direct that pointer to an allocated source of memory that's the size of the structure, which we will have in this first function. So then we will do a while loop. Whoops. While, or maybe for is better here. For int I equals 0, I is less than equal to I is less than or equal to size, because we're going to change every byte, and this really should be size minus 1 because of indexing. Since it's starting at 0, everything has to be shifted to the less by 1. So we're going to be going byte by byte, changing it, and as we're iterating through, this will look like this. Hold equals. We should make another pointer that we can actually dereference, and we'll call it location as well. And we will make this equal to, whoops, that's an H. We'll make each one, now we can use arithmetic and, what is the word, indexing, to walk around the structure. And we can make hold equal to the location of of byte I, and then we'll make, what we're going to be dealing with is two structures next to each other, and the structures will be equal to a certain number of bytes apart, which would be the size. So what this will look like is location location plus size, so that's the next item in the list, and you can still dereference that like that, and that will be equal to the hold. And I think I did this in the wrong order, so let me just adjust this. There needs to be one more step in between, where location I becomes the next one in the series. And so that means I will just have to copy that and paste it here and grab this. I just did it in the wrong order. So this means that hold will switch with the first item will switch with the second item, and the second item will become hold, which was the first. So that's how you switch things in coding. And then after this, you just have I think I had too many indents here. Delete that line, and so this is how we will switch items, and then now we have this swap location up and swap function up and running. And I also need to copy this. So this will right now this will not go through the list. It will only deal with the first couple of items over and over. So the way we will have to walk through this list is by making another while loop, and we will say while I is less than or equal to the length of the list, and we will have to make it -2. And the reason for that is because normally you'll have to make it -1 because this is a index position and this is an actual value. So to make this an index value, you have to -1. But the reason you have to -1 an additional time is because we will be moving with this swap function. We will be moving a value and the next one in the series. And the thing is that the way these lists have been constructed is that there is a sentinel value that we can look for that will tell us when to stop. And it might, yes, it would be better to just do it that way, to look for the sentinel value instead of trying to find the length. So what we can do instead is while, and the sentinel value will be a 1 at the location of the address. If you, let me save this and go back to the university header file. So this course ID here is the first item in the series, and that holds the sentinel value, which is a -1. And similarly for the students, so that is one part where they are compatible. So what we will be doing in this while loop is looking for that sentinel value, and the way we can do that is by changing the character pointer to a integer pointer like that, and this will be converting address plus it would not be plus, it would be yes, it would be. Okay, it would be plus size times I. because what this allows you to do is each time size increases, you are moving one step up in the series. So now we will also add somewhere around here, I think here's a good spot, int I equals 0. I also have to add this here. And then at the end of this while loop, I will make I increment. And so what this allows you to do is the first run will be on the first, the 0th element, and then on the second run I will be 1 and will increase by size, number of bytes. And of course you have to dereference this and compare it to 1. And if it's, as long as it is not -1, this will continue to loop. And then once this is done looping and it breaks out, you have to return I back to 0 so the loop can begin again. We'll move that. Oops. Really, all this stuff should be tabbed out. Oops. Whoops, whoops. Alright, that's a little bit better. So I'm getting a red here because I see. I need one more of these. Not sure what that's about. Anyways, this will loop until it gets to the end of the list, and while it's looping, it will check if the characters at, since these are character pointers, these are dereferenced, and it will determine whether the characters are in alphabetical order or not, and if they are not, it will swap them, and this value here will increase, indicating that a swap has occurred. And then once this gets to the end of the loop, I will be reset so that the loop can begin again at the start of the list, and then J will be evaluated to see if a swap has occurred, and if a swap has occurred, then it will have to loop through each item in the list to check if they're in alphabetical order one more time. So now we can begin testing this, and to begin testing it, we have to write the function somewhere in our main so that we can see the output. And let's start with the courses. So we will write here sort, and we will pass the address, which will just be courses, and then the size, which will be size of course, the type. And I just realized we also need to determine what value we're sorting by. So this says to sort by instructor last name. So we need to go back up to the prototype and add some kind of address for the relevant value. We'll call it just value. It's a void pointer. And we will make that here. And this if statement here, what we're comparing, this only compares the course number because it's pointed to the first item in the course. So what we actually have to do is change this, instead of location, we need to change this to, this should not be value because that's already taken. It should be value pointer. So now we need to change this to value pointer, and then value pointer plus size, which is the next one on the list. And we will still be swapping according to the location of the beginning of the structure, because if we switch according to the value pointer of the structure, we may only be switching half of the entire structure and you'd be mismatching all the data. So you need to compare the important part, but you need to switch starting from the beginning. So now we need to go back to this function here and add the pointer to the relevant information. And that is done by doing courses dot instructor last L name 0. Actually, that's not where you put the 0. You put it here. For the first item in courses, you go to the first item in the character array that has their last name, and that will, these two addresses together will allow you your sort function to work. So let's see how this all happens and what errors we will probably get. Alright, semicolon, I is undeclared, unused variable. Alright, these all seem pretty minor. Oh, and of course, malloc is not part of standard I/O. That is part of the standard library. Alright, that should solve that. I am missing a curly brace somewhere. Huh. It's crazy. I should have looked at the numbers. Perhaps I missed a curly brace in this one and it's bleeding into my other function. And main has enough. Let me see what, oops, I just took out my malloc library because I did control L, or Q exclamation point. Alright, so this is line 9, I believe, or line 10, 13 and 14, 13, 52. Okay, let's go to line 13. While can at least set this one again. Oh, and of course this needs to start off true, the j value. If it starts off at 0, this loop will never happen. And the idea is that it starts true, immediately becomes false, and then has to work back up to being true for this to continue. And it becomes true if a swap occurs. So where is the missing curly brace? Okay. The problem is not that I don't have enough curly braces, it's that I had not enough parentheses, and that ate up my curly braces and the rest of my code. Okay. And I also need to declare I outside of this while loop. And that should solve that. Alright, so I need to add a semicolon here. I need to I need to check to see if I have these. Location, size. Location undeclared. Whoops. I think I really need to declare both these outside of the loop. Okay, and that will let's see if this has lowered this at all. Alright. Oh, what I need to do is change the order. So what I can do is grab all of this and move it to the top. Okay. Okay, what that does is it allows swap to be defined before it's used here. And I also need to add another parenthesis here because it's accidentally comparing this before it's being dereferenced. Oops. And I think this might be one too many parentheses. Whoops. That should not be there. Yeah, and that should be... Oh yeah, of course, that should be initialized right away to be equal to the value, address, and the location should be equal to the address. And this should not be address, this should be location. Alright, no errors. Let's see what we get. Of course, we have to actually see our outputs. So what we need to do is, since we're dealing with courses, let's print the courses initially and then sort them here. and print them out again using the function print courses. And let's put some information here. Sorted courses. All right. So starting from here, we have it sorted by these numbers. So that's a good way to see that it's unsorted. And then once it gets to here, these still seem to be sorted by numbers only. It looks as if nothing, the if statement was never triggered. Let's look into that. So it looks like swapping never happened, which might mean that this was not correctly dereferencing a character. Let's look at what this does by just copying all of this. And then we can say printf character and character. And then we can put this information there, change this to a comma. And now this will show us what's happening behind the scenes. Expected a parentheses. Whoops, looks like I did that same mistake again. That should solve both those errors. All right, so, okay, so if it's comparing the same thing over and over and over like it is here, JNR, that likely means that it is not walking through the list correctly. So this isn't a problem on our if statement, it's a problem on our while loop. So I should be incremented each time. This should really be indented one more. Or, okay, I think that's actually correct. So if I is of course, we aren't swapping the right location, so we need to be indexing this correctly. All right, that should be passing argument. Pointer from integer. All right, we actually have to make this an address so that it's actually pointing somewhere, because that was simply a variable holding data and not the address. And it still seems to be getting stuck. Oh, of course. This, rather than doing it that way, the problem is that that's going up by 1 byte each time you, if this is a 5 or if that's a 3, you're going up by 3 bytes because it's a character, not a structure pointer. So what we actually have to do is, after each iteration of this loop, we have to change location we have to increase it by size. And that is equivalent to going up 1 step in the structures. And that would change this if statement, or actually it won't change the if statement either. We have to change that as well the same way. And that brings it up to the next step. So that changes this if statement, and that changes this swap statement to be correct. And if we compile this and run it, we can see that initially it seems to be going correctly, J to R, and then R to N, and R to U, because R and N switched places. And then U to Z, Z to W, Z switches places with W, and switches with R. Each time you see this repeat, that is because it took the place of the next number. And that is good because that means, first of all, it's stepping through correctly and it's changing all the data correctly as well. But what I forgot to do was, at the end of the loop, bring both values back to their starting locations. So we can do that very easily just by, at the end of this loop, along with I returning to 0, we have to bring location back to address, and we have to bring value pointer back to the value location for the first elements here. And now, once we compile and run this, it will do the process this many times, and it is sorted by professor last name. But it's not that easy to see because it doesn't show the professor's last name. What we can do to test this actually works is, since we wrote this code to be versatile, all we have to do is change this to be, instead of sorting by instructor last name for the first element, we can just say the name of the course. Now if we run this, it'll sort by the name of the course, A, I, O, O. That doesn't seem quite right. And then W, then I. Let's look at here. We have I to I to W, W to O, W to W because these switch places. And then it seems to have jumped back to the top because it goes back to the A's, which are here. So perhaps it didn't read the sentinel value correctly, and it might be ending too early. Let's look into it. So we have, this is where we check for the sentinel value. And these numbers should be equal to the course numbers like 1050 or rather, is that true? Let's see, how are they actually organized? Yes, so like 1050, 2050, it should never be equal to -1. So here, we are checking to see, we have to convert the numbers located at the beginning location for the element. Oh, okay. So we increase the size here, but we're also increasing the size here simultaneously, and that's making this double. So if you look back at the output here, right about here, A, it's comparing these first two items, algorithm design 2, and then it goes to the next, algorithm design 2, and intro to computer science. And it only goes 6 courses down before the loop ends, which is really suspicious. But the reason is because this location is increasing at twice the rate, because I is increasing each time and location is increasing each time. So what we have to do instead is delete this information. And if you look at this, it's actually organized correctly for the first 6, like it should be, but it's the last 6 that are unchanged. Expected expression. I think I put too many. There we are. Too many parentheses. Whoops, now we have an infinite loop. And I believe that happens because we may have overwritten the sentinel value, which was the fear. And yes. So we actually need to test one size up from this. Like I said, we have to go, we have to check 2 locations ahead, because we'll always be swapping the next item in the list. So if you're at the last item in the list and you find out that you need to swap for some reason, you'll be swapping with the sentinel value and it'll mess everything up. So you need to be checking 2 items ahead. So or rather 1 item ahead, because this is a different system than what we had initially in the first 5 minutes or so. So if it finds the sentinel value at the next item in the list, then it won't be considering whether to swap or not. But I think since we didn't have this here, checking the next item in the list, it was swapping for some reason that I'm not sure of, and it was breaking the sentinel value. So this protects us from that. And if we make and compile this again, these are all sorted alphabetically, and now we know for sure that our program's working correctly. So going back in, we should change this back to the way they want it, where it's going by instructor last name. And then we can begin step 2, which is sorting the students by last name. And because of our program using pointers and addresses instead of types, we can use the same function, just changing the value to the students list. And that's the address to the first item in students, then the address to the first item that we care about in students, which is the last name, and then the size of a student type, which will allow us to step one unit in the list, one size of the students. And then we can print out print students. Is that the correct? All right. And we should unblock this. And I think we should add some more space for all this because it's starting to it will begin to become very crowded. And we can put here, sorted students. And we can see how that works. We should probably take this debugging device out of our code, but we can look here, C, E, H, 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 J. This is all in alphabetical order. And then finally, step 4, print out the list of students who are in CS 1050. In step 3, they changed the students list to include students in CS 1050. So we don't have to do much for finding these students as much as organizing them, but we have already found a foolproof way to organize them. So we can just do this all again, sorting by last name, size of student, and then print students. And of course, putting it out there that this is a sorted students in 1050. And now we can look at our program as a whole. Oops, wait. Scratch that. We need to go back and take out this debugging. Let's try this again. Clearing out the way. And starting at the top. Okay, starting at clear. We have our courses listed by number instead of name, and our students listed by number. And then we sort the courses by instructor last name. And then we sort the students by their last names. And then we print out the students in 1050 and then sort them by their last names. And here is one last look at the code. And I'm glad we all got to work together to make this happen. And I hope you guys have a great summer and have a fun end to your semester.